Alright gang, so this is CTS1150 A+ hardware software. Now we're going to start out with Chapter 1, and it's a first look at the computer parts and the tools that we'll use as a computer technician. Alright, now the objectives, we're going to identify the various parts inside a desktop computer, the case itself, or we'll call it the system unit, describe how they connect together and are compatible, and identify the various ports, slots, and internal components of a laptop computer, and explain special concerns when supporting and maintaining laptops. Now we're going to describe various hardware components and mobile devices and types of wired and wireless connections mobile devices can make. We're going to describe the purpose of various tools you'll need as a computer hardware technician. So let's get started. What's inside the case? A computer case, sometimes called a chassis or a system unit, it holds a power supply, motherboard, processor, memory modules, expansion cards, hard drive, optical drive, and other drives. Now, we don't always have expansion cards. We don't always have an optical drive. But there are things that we do have to have. Now, a tower case sits upright and can hold several drives. A desktop case lies flat and sometimes holds a monitor. Mobile case used with laptops and tablets. And then there's the all-in-one case used with all-in-one computer. Okay. So let's start out with ports. Now, a port, we're looking at a VGA port here. Now that's a display port. It's also called a DB15 port, an HD15 port, or a DE15 port. Now 15, remember that. DB15, HD15, 15 pins in it. It's D-shaped. Okay, DB15, it's an analog. That means continuous signal with infinite variations as compared with digital, which uses binary ones and zeros. Now, older monitors use VGA ports. What we'll see now will be, we've got HDMIs on a lot of them today. And we also have an S-video port. Now this is the S-video port. To a degree, it kind of looks like older mouse or keyboard connections. It's 4-pin or 7-pin round video port, sometimes used to connect to a television. The 7-pin port is shown on the left. The 4-pin port is missing the extra pins in the middle. Won't have these in here. It's the more common type. So here's some different ports that we may see. So here we've got a DVI, digital video interface port, HDMI, a display port, Thunderbolt port. So it's a port after port after port. Now, we've got exercises to walk you through these step by step. And everything that you see here is there. You've got to get comfortable and be able to recognize each one of these and know what they do and how they do it. Now here we are. We've got PS2 ports, keyboard and mouse. You need to know what one's green, what one's purple. We've got external SATA ports. That's these red ones. And older serial ports, we don't see them anymore. It's a D89 port. It's a 9-pin. Now parallel ports or LPT ports is 25-pin female port. It's used by older printers. Printers today will use a USB port. There's modem ports. There's an RJ11 port. Now that's a phone connection port. Now the system case itself, when we look at it, you can see the power supply, optical DVD. So an optical drive is a CD or DVD drive. We've got power cords. Over time you'll get comfortable with recognizing which power cords are supposed to connect to the motherboard, which ones connect to different drives, how they connect, whether it's an IDE drive or it's IDE or PATA, or it's a SATA connection, and we see some SATA connections here. So we've got 2 hard drives mounted in here. You see the motherboard, some SATA cables. Now, motherboard is sometimes called the system board. It's the largest, most important circuit board itself. The processor is the CPU. It processes most of the data instructions for the entire system. Now, it can generate a lot of heat and needs a heat sink on top of it. And we see the heat sink here, these little blades. Those blades create a great deal of surface area for air to flow across and exchange heat so that the heat is removed. These fans always pull air away from the heated unit. They don't blow air onto it. Now, these are all integrated ports integrated into the motherboard. So we've got functionality that previously was only available in expansion cards. Now, for time and efficiency and trying to cut costs, they've got these things integrated into the motherboard. Now, that doesn't mean that we're stuck with them. There may be an expansion card that we can plug in, or a expansion slot that I can put a card in should one of these fail. But we always got to keep in mind, if this failed, likelihood is the one next was potentially going to fail, depending on the cause of the failure. Now, heat is the #1 thing we need to worry about, thus the fans. Everywhere we look, we see fans. Now, we've got memory modules. Now, these are slots, they're DIMM slots for sticks of RAM, random access memory. Now, temporary storage of data for instructions that are being processed by the CPU. Your desktop exists in RAM. It's volatile short-term memory. Volatile meaning, should the power go out, whatever was being stored in RAM is now gone. Okay, so now we've got hard drives and other types of drives. Now, here's an optical drive. It's a CD or a DVD drive. Here's a hard disk drive. This one happens to be an HDD. We've got newer ones that we see here is an SSD. We've got optical drives and tape drives. The SSD doesn't have any moving parts. It works similar to the concept of an SD card, but it has more functionality to it because it's got a power connection going to it. All right, now a power supply, also called a PSU, it receives and converts current from your home depending on whether it's 115 or 220 volts. You may see 110 and 220, or you may see 120 and 240. It's depending on who's writing it, on how they're going to say it, and we're roughly 115 volts in the U.S. Okay. Now, form factor describes the size and the layout of a motherboard, and their screw hole positions align from one form factor to the next. So that if I had an ATX, a micro ATX will mount where an ATX mounted. Now, it may not have the same airflow and it'll have limited functionality, but the hole mounts are usually about the same, and that possibility is there to change from a bigger form factor to a smaller. Okay, so we've got ATX, Advanced Technology Extended, most commonly used form factor today, originally developed by Intel in '95. Now, smaller form factors are becoming more fashionable because these desktops are taking up smaller and smaller footprints. Okay, we've got a 20-pin P1 connector. It's used by the ATX power supplies and motherboards. There's a 4-pin and 8-pin auxiliary connectors used for 12 volts to feed power to the CPUs. You got a 24-pin or 20 plus 4-pin connector, and older 20-pin P1 connectors still worked on this connector. It's supported for new PCI Express slots. There's also a 6-pin and an 8-pin PCIe connectors connected directly to the video card itself. So these power supplies have got a bunch of different cords coming off of them, feeding power to the motherboard and other items. Okay. Got a micro ATX form factor. Like I said, that will fit the same place that an ATX would sit. It uses a 24-pin P1 connector. Not likely to have as many extra wires and connectors as those on the ATX power supply. They're cheaper, takes a smaller footprint, but that's a lot of times they will get you where you need to be. And here's what they'll look like. Okay. Now hard drives. We've got two standards. We've got what's current is serial ATA standard or SATA, and the older version, also called IDE interface, it's a parallel ATA or PATA. Extremely faster. I mean, SATA is extremely faster than PATA. PATA is so slow compared to where we're at today. It used a 40-pin ribbon cable and connector, the two connectors on a motherboard for two data cables. It's found in most older desktop computers, and you'll see sometimes power supplies that have both SATA connections and PATA connections. Now, a laptop or a notebook is a portable computer. Now, there's a variation of a laptop as a netbook. It's smaller, less features. And if we're comparing laptops and desktops, they use about the same technology. They're just smaller, portable, and they use less power. Replacement parts cost more than desktops because they are so small, and it costs more to build something that's smaller, at least in IT. Laptops offer a variety of ports and slots, but we won't see expansion cards in laptops because of the way the cases are designed. So we've got, here's a VGA port. We looked at those before. Here's an Ethernet port, an SD slot, a Magic Gate slot, HDMI. Got a couple of USB 3 ports we could see by the blue inside, and a standard USB 2 port. And then there's a DC jack. That's where our DC or direct current power feeds this unit. Now, the difference being, in a desktop system, the power is converted inside the power supply. You've got a cable that comes from the wall to the power supply, and then the power gets converted inside the power supply itself. Now, when it comes to a laptop, the power is converted usually about a third of the way through the power cable. You'll see a little box, rectangular in shape, and that converts it from 110 volts AC down to a DC current. So over here we've got a optical drive, probably a DVD drive, a speaker port, microphone port, and a cable lock. Okay, now commonly we'll see a USB to RJ45 dongle for a connection if we want to connect to a wide area network. Now, RJ11 is phone, RJ45 connection is network. Okay. Now, one of the things that you would have seen in the past is that if a network card went bad or an integrated network interface on the motherboard failed, we could just add a new network interface card on there. And they've become old technology today. Today, if you've got a USB port, especially if it's a USB 3 port, it gets even faster. But if we got a USB port, we'll just connect this connection to a USB and connect our RJ45 or our network cable to this connection, and now we've got a network connectivity. Now, that's if we're hardwired. We've also got the ability to be USB to Wi-Fi, and just by plugging in this little connection, we can have Wi-Fi on our laptop should our Wi-Fi adapter that was built into the unit fail. Same devices can be plugged into a desktop as well. Buttons or switches might be above the keyboard, and most of the same settings that these buttons control may also be changed using Windows tools Now, on a laptop, some of these settings might be volume, keyboard backlight, touchpad on, dual displays, Bluetooth or Wi-Fi on, media options, GPS on or not. We've got ExpressCard slots. Most peripheral devices on today's laptops use a USB port to connect to a laptop. Okay, slide on through. Now, docking station. Now, it's a bay that you would connect your laptop to that will help it act as a full-size computer. It will have a full-size monitor, keyboard, AC, power adapter, and everything already connected to it. You'll just dock your laptop into it, and then it'll act like a full computer. We'll call them a docking station. Now, if I open up the bottom of the case of a laptop, now they're not always the same. It's dependent upon the manufacturer. Now, this cover's been removed, and we can see the hard drive here. We see the fan over the CPU here. We see RAM is installed here. The wireless access card and the antennas here. Screws would secure this case or the cover over it. The motherboard is what we see blue in the background there. All right, there's a heat sink here. Actually, the motherboard's here, or the CPU's here. You can partly see it here. And the fan is over here. So it's working in tandem between the heatsink and the fan. Now, some important components in a laptop: battery pack, hard drive, CPU, heatsink and fan, memory, wireless card, system board, and optical drive. We don't always see optical drives anymore. An all-in-one computer uses a mix of components sized for a desktop and a laptop. So here's our all-in-one. Now, maintaining laptops and mobile devices, general guidelines: do not touch LCD panel with a sharp object. Don't pick up or hold by the lid. Use OEM recommended battery packs. Don't use aftermarkets. Do not tightly pack in a suitcase. Use a carry case. Don't move while hard drive is being accessed or while the computer's on. Don't put close to appliances generating strong magnetic field or heat. Always use passwords to protect your laptop when connected to a public network, or if the device is stolen, you would have that protection. Keep a notebook at room temperature. Keep away from smoke, water, dust. Do not power up and down unnecessarily. Do not run it while it's in the case, resting on a pillow, or covered by a blanket. It will catch fire. Protect notebook against ESD, electrostatic discharge. That's that charge you get when you rub your feet in the winter on the carpet and then tap somebody and shock them. We use a grounding strap to avoid that when dealing with computers. Remove the CD, DVD, or USB flash drives before traveling. Take precautions if the notebook gets wet. Keep current backups of important data. Now, when it comes to cleaning, clean an LCD panel with a soft, dry cloth. Use compressed air to clean the keyboard, trackball, and touchpad. You can blow out vents, but don't blow the fan itself. Remove the keyboard if keys are sticking, then blow air under the keys. Now, not all keyboards come off the same. That's something you may want to leave to somebody that's got better understanding, or do your homework and check to see if there's a video or some direction on how to remove the keyboard or keyboard keys. Now, they're saying blow air under the keys, but I've seen air blow under the keys and dislodge the keys or cause a failure. Use contact cleaner. Remove the battery and clean the battery connections. Now, a smartphone is a cell phone with added capabilities. Its ability to send, receive text messages with photos, videos, and other multimedia content. Web browsing, manage email, play games, take photos and video. It uses a variety of applications. Now, a tablet is larger than a smartphone with similar functions. Most connect to Wi-Fi and Bluetooth, and some have cellular network connectivity. Some can make phone calls and use MMS. Phablet, some capabilities of a smartphone or tablet. So let's look at different connection types. Now, some ways mobile devices connect to outside world are Wi-Fi, local access, and a cellular network. We've got Bluetooth and infrared, near field communication or NFC, a wired connection, and tethering and mobile hotspots. Okay. Now, a mobile device has a gyroscope or accelerometer, and it's motion and position sensing device. It helps it adjust the screen orientation when you move your phone around. It's also got GPS that reports the signal so that the OS knows where you're at and can track your location. It will burn up your, or use up your memory, or use up your, I should say, your battery pretty fast. Now, mobile devices store apps and store data on a solid-state drive, a type of flash memory. A device may have an external slot for a smart card or an SD card and provide extra storage. And we see one right here. Examples of accessories: wireless keyboards, speakers, earbuds, headsets, gamepads, docking stations, printers, USB adapters, credit card readers. Now, there are a few FRUs, or field-serviceable parts for removing devices in mobile devices. Now, it's possible to replace screens in some mobile devices, but what you're doing when it comes to this A+ course is not about swapping out screens on iPhones or Androids. Now, SIM cards and batteries, you're usually easy to replace. All right, so we've got essential tools. We've got the ESD strap or grounding bracelet. Like I said, ESD, that's electrostatic discharge, or that shock from static electricity. Now, that's not to protect you. That's to protect the device itself from the charge you would emit. A flathead screwdriver, very common tool. Phillips head screwdrivers or a crosshead screwdriver of different sizes. Torx head screwdriver set, preferably size T15 if you don't have the whole set. Insulated tweezers. We don't want them becoming magnetic. We need an extractor, an OS recovery CD or DVD, or it could be on a thumb drive. Many other non-essential tools exist. A toolbox, a voltage checker. There's so many different things that we can add into this toolbox when it comes to being a computer hardware technician. Okay, they're all different ones. There's a volt to ohm meter. Sometimes we'll even have a board that has all kinds of devices on it that we know function, and if we want to check to see if something works, we can just connect it to our system. All right, these are cable testers, power testers, flashlight to see in there, zip ties, and a number of different things in here. Can of air, and there's our tools. Okay. Now this one is a post-diagnostic card. It helps discover, report computer errors and conflicts at the power on or post test. Test performed by startup and the UEFI and BIOS. Okay. It's a great little diagnostic. Now, firmware is programs and data stored on the motherboard. There's two types of firmware that may be used. Now, the legacy, what was used in the past, is BIOS. Currently, the latest and greatest is what we call UEFI, Unified Extensible Firmware Interface. Okay. BIOS is basic input-output system. Now, the difference being BIOS has stored all the information on the motherboard itself in a ROM chip. UEFI stores this stuff on the hard drive. Okay. So we can have a power supply tester. Now, there are different types of power connections, but they're looking at the most common here, and it'll tell you if the power supply is working and putting out the right voltages on each one of the connections. All right, they're not expensive, and they're very useful. Now, a multimeter, or what we call a volt-ohm meter, this is a low-end one, measures different characteristics, AC, DC, ohms. Here's DC, AC volts, and ohms, and you can scale it on up depending on how high a voltage that you want. And this one's testing continuity. So here's a loopback plug, and it's used to test a port in a computer or other device to make sure that the port is actually working. It'll tell you the speed of the port as well. So ports on a computer might include the video port, an RJ45, audio, SPDIF, USB, FireWire, eSATA, PS2. We did see an RJ11 at one point. Now, internal computer components include a motherboard, processor, expansion cards, DIMM modules, hard drive, optical drive, tape drive, and power supply. Form factors used by cases or the size and configuration of the motherboard. Power supplies and motherboards are ATX and micro ATX, the two most common. Power connectors include 20-pin, which is a P1, 24-pin P1, 4-pin and 8-pin auxiliary motherboard, 4-pin Molex, that's the most common connection you'll see, or you'll see the most of, that or the 15-pin SATA. You need to recognize every one of these pins by sight and know what they are and distinguish them from any of the others. Okay? So, in an all-in-one computer, it uses a combination of components designed for desktop computers and laptops. Mobile devices and IT support technician may service smartphones, tablets, phablets, e-readers, smart cameras, GPS devices, wearable technology devices. A mobile device might make a connection using a cellular network, Wi-Fi network, Bluetooth, infrared, NFC, tethering, or creating its own hotspot or a wired connection. Now, a common tool for computer hardware technician include an ESD strap, both straight and Phillips head screwdrivers, tweezers. Now those tweezers were insulated, flashlight, compressed air, and cleaning solutions and pads. Always be careful when you're using cleaning solutions because some of them are more corrosive than others. And if we're not sure about what we're doing, it could take the letters right off your keyboard or put a gray haze over a monitor. And that's not something that's worth the aggravation. So always know what we're doing before we go to use any kind of solution. Now, there's special tools a PC support technician might need. Post-diagnostic card, power supply tester, multimeter, and loopback plugs. All right. Now that's it. Chapter 1. We got 20 chapters in this book. We got a lot of ground to cover. So I'll see you in the next one.